The universe is vast, so vast that it seems almost impossible that we're the only intelligent life out there. But if that's true, where is everyone? This is the mystery at the heart of the Fermi Paradox, one of the most fascinating questions in science. Stick around as we explore the possibilities, theories, and what they mean for our place in the cosmos. It all started with a simple question posed by physicist Enrico Fermi in 1950. Where is everybody? Fermi was struck by the contradiction between the high probability of extraterrestrial civilizations existing somewhere in the universe and the complete lack of evidence for or contact with such civilizations. Given the age and size of the universe, it seems like we should have already encountered intelligent life, but we haven't, or at least not yet. To put this in perspective, our galaxy, the Milky Way, contains over 100 billion stars, and there are potentially more than 2 trillion galaxies in the observable universe. Even if only a small fraction of those stars have planets with conditions suitable for life, there should still be millions, if not billions, of planets with intelligent civilizations. With all those potential neighbors, why haven't we heard a peep? Scientists and thinkers have proposed a wide range of explanations for the Fermi Paradox. Let's take a look at some of the most intriguing ones. The zoo hypothesis. What if advanced civilizations are aware of us but have chosen not to interact, observing us like animals in a zoo? Maybe they're waiting for us to reach a certain level of technological or ethical maturity before making contact. The central idea behind the zoo hypothesis is that advanced civilizations follow a strict policy of non-interference. They may have decided that direct contact with a less advanced species like humanity would disrupt our natural evolution, much like how human researchers might observe wildlife without interfering. This approach could be driven by ethical considerations, a desire to preserve cultural diversity, or even a scientific interest in observing our development. The hypothesis assumes that these extraterrestrial civilizations are far more advanced than we are, not just technologically, but also ethically or philosophically. They may have long ago reached a level of technological sophistication that allows them to observe us without being detected. Their ethical framework might prioritize the protection of developing civilizations, similar to how humans might protect endangered species or isolated indigenous tribes. According to the zoo hypothesis, there could be a galactic community of advanced civilizations that have agreed upon a set of rules governing contact with less developed species. Only when a civilization reaches a certain level of maturity, technological, cultural, or ethical, might it be invited to join this community. Until then, they remain under observation, unaware of the greater galactic society around them. Under this hypothesis, humanity is seen as not yet ready for contact. We might be considered too primitive, too aggressive, or too divided to interact with more advanced beings. These civilizations might be waiting for us to reach a certain milestone, such as achieving a stable global peace, solving critical planetary issues, or developing faster-than-light travel before they make their presence known. The advanced civilizations could be using highly sophisticated technology to observe Earth and humanity. This might include cloaked spacecraft, advanced probes, or even forms of observation we cannot currently comprehend. They could be monitoring our planet's electromagnetic signals, studying our cultural and technological progress, or even subtly influencing events in ways that remain hidden to us. Technological limitations. Perhaps civilizations exist, but they're too far away for us to detect them, or their communication methods are so advanced that we simply can't recognize them. They might be using technology beyond our understanding, like neutrino beams or quantum entanglement, which we haven't yet mastered. Much of our search for extraterrestrial intelligence, or SETI, has focused on detecting radio waves, based on the assumption that advanced civilizations would use similar communication methods to our own. However, radio waves might not be the preferred communication medium for other civilizations. They could use technologies that are either more advanced or more efficient than anything we currently possess, making them undetectable by our equipment. Our radio telescopes and other instruments only cover a tiny fraction of the sky at any given time. The universe is vast, and we have only begun to scratch the surface in our search for extraterrestrial signals. Additionally, signals could be directed towards specific targets rather than broadcast widely, meaning we might miss them entirely if we're not looking in the right direction at the right time. Advanced civilizations might have moved beyond radio waves long ago. They could be using laser communication, neutrino beams, or quantum entanglement for faster-than-light communication. These methods would be far more efficient than radio waves, but are currently beyond our technological capabilities to detect or understand fully. Another technological limitation is the possibility that civilizations arise and develop at different times across the galaxy. If a civilization reached its technological peak millions of years ago and either self-destructed or moved on, their signals might have passed Earth long before humanity developed the means to detect them. Similarly, future civilizations may arise long after humanity is gone, leading to a temporal gap where no overlapping communication is possible. The Great Filter. The theory suggests that at some point, from pre-life to advanced spacefaring civilizations, there is a highly improbable step or event that drastically reduces the likelihood of a civilization progressing to the next stage. This filter could be a biological, technological, or environmental challenge that prevents civilizations from reaching the stage where they can communicate or travel across the stars. The first great filter could be the initial emergence of life itself, known as abiogenesis. If the transition from non-living chemistry to simple life is extremely rare, this could explain why the universe seems devoid of life despite its vastness. The leap from simple single-celled organisms to complex multicellular life might be another filter. For billions of years, life on Earth was dominated by simple forms, and the development of complex organisms may be an exceedingly rare event. The evolution of intelligence capable of creating technology could be another significant filter. On Earth, many species are intelligent, but only humans have developed technology. If this step is rare, it might explain why we don't see other civilizations. One of the most discussed future filters is the idea that civilizations inevitably destroy themselves once they reach a certain level of technological advancement. This could happen through nuclear war, environmental collapse, or the misuse of artificial intelligence. Civilizations might exhaust the resources of their home planet before they can become spacefaring, leading to their decline or collapse. Unsustainable use of resources could prevent them from advancing further. Societies might reach a technological plateau and stop advancing, or they may choose to isolate themselves, becoming uninterested or unable to explore space. Cultural or political factors could lead to stagnation or regression. The Metaverse. Advanced civilizations might reach a point where they decide that exploring the cosmos physically is unnecessary or inefficient, compared to creating and expanding within their own virtual realities. Instead of investing in space exploration, they may choose to immerse themselves entirely in a highly advanced metaverse, where they can simulate any environment, experience, or scenario they desire. If civilizations are fully engrossed in their virtual worlds, they may have little to no interest in exploring or communicating with the physical universe. As a result, they would not be sending out detectable signals or attempting interstellar travel, leading to the apparent silence we observe. As technology advances, a civilization might transcend its biological roots by uploading its consciousness into a digital medium. This post-physical existence would allow them to live indefinitely in a controlled, perfect environment without the risks and limitations of the physical world. These digital beings could reside entirely within a metaverse, effectively leaving the physical universe behind. Simulation hypothesis. If our universe is a simulation, it's possible that the creators of this simulation intentionally designed it to contain only one intelligent civilization, us. This could be for various reasons, such as to study the development of a single species, to observe our behavior, or to see how a society evolves in isolation. The lack of evidence for other civilizations could simply be a feature of the simulation, not a reflection of the true nature of the universe. The Fermi Paradox would then be an illusion, a byproduct of the creator's decision to exclude other civilizations from the simulation. A simulation, no matter how advanced, would have finite resources. Processing power, memory, and energy would all be limited, even for the civilization running the simulation. To conserve these resources, the creators might choose to simulate only one civilization in detail, leaving the rest of the universe relatively empty and less computationally intensive. If a civilization reaches the point where it becomes aware that its reality is a simulation, it might cease to function or lose interest in physical expansion. This realization could lead to a societal collapse or a shift in priorities away from exploring the universe. The Fermi Paradox forces us to confront profound questions about our own future. Are we alone? If not, will we ever find others? Or will we remain isolated in the vastness of space? Understanding this paradox could help us chart our path forward, guiding our search for life beyond Earth and shaping our role in the cosmos. Whether the answer lies in the stars or within our own limits, the Fermi Paradox challenges us to think bigger, dream further, and perhaps one day reach out to the stars ourselves. So what do you think? Is there intelligent life out there, or are we truly alone? Let us know your thoughts in the comments below. Don't forget to like this video, share it with your friends, and subscribe for more explorations of the biggest questions in science and space. Until next time, keep looking up.